Good morning everyone. Welcome to TUTOR LOKESH channel. So ఇవాళైతే ఈ వీడియోలో మనము ప్రూఫ్ ఆఫ్ ట్రిగ్నోమెట్రిక్ ఐడెంటిటీస్. సో మనకైతే తెలుసు ట్రిగ్నోమెట్రిక్ ఐడెంటిటీస్ అయితే మనకి 3 ఉన్నాయి. ఏంటంటే అవి sin square theta plus cos square theta is equal to 1 and secant square theta minus tan square theta is equal to 1 and cosecant square theta minus cot square theta is equal to 1. సో ఇవి మూడు అయితే మనకి ట్రిగ్నోమెట్రిక్ ఐడెంటిటీస్గా మనం చెప్పుకుంటాం. అండ్ ఆల్సో ఈ రెసిప్రోకల్స్ అంటే ఏంటి, అంటే దేని రెసిప్రోకల్ ఏంటి, అండ్ ఆల్సో మనము యాక్చువల్గా ఎందుకు సైన్ థీటా ఈజ్ ఈక్వల్ టు సైన్ థీటాకి ఆ పేరే ఎందుకు పెట్టాం అండ్ టాన్ థీటా ఎందుకు టాన్ థీటా మాత్రమే అంటాం. సో ఇటువంటి అంబిగ్విటీ ఉన్న డౌట్స్ అండ్ హైపోథెటికల్ క్వశ్చన్స్ ఏవైతే ఉన్నాయో అవన్నిటికీ ఒక ఆన్సర్, ఒక క్లియర్ కట్ ఆన్సర్ అయితే నేను చెప్పే విధంగా ఈ వీడియో అయితే మీకోసం చేస్తున్నాను అనమాట. రైట్, ఇంకేమాత్రం ఆలోచన చేయకుండా మనం వీడియోలోకి వెళ్ళిపోదాం. ఫస్ట్ ఆఫ్ ఆల్ see, we know that trigonometry is applicable to right angle triangle. Let us draw a right angle triangle. A, B, C. Now if we have theta here, that means our angle of elevation or angle of observation point. See, let us assume BC as some O since it represents opposite side, and let us assume AB as some A because it represents adjacent side, and AC as hypotenuse H. I'm telling you once again, since BC is standing opposite to the angle, opposite to the observation point, the observer is here, okay, from his point of view BC is opposite direction, so that is why BC is known as opposite. And here AB is adjacent to angle theta. Here AB is adjacent to angle theta, that means it is beside him. Okay, it is not opposite him, it is beside him, that's why it is known as adjacent. And we know the longest side of a triangle is known as hypotenuse, let it be H. So here we are assuming BC as opposite side O and adjacent side as A and hypotenuse as H. Now there is no exact proof or something like we have to define sin theta. There is nothing like there is exact proof. Okay, so the thing is, we will assume opposite by hypotenuse. We will assume opposite by hypotenuse as sin theta. We will assume opposite by hypotenuse as sin theta, and we will assume adjacent by hypotenuse as cos theta, and we will assume opposite by adjacent as tan theta. Okay, we will first of all we will assume that thing, and now based on this we have other 3 secondary ratios. These 3 are known as primary ratios. Sin theta is equal to opposite by hypotenuse, cos theta is equal to adjacent by hypotenuse, and tan theta is equal to opposite by adjacent, and these are known as primary ratios or main ratios. See, though there is not actually a proof behind this why actually sin theta is equal to opposite by hypotenuse, yet we can prove it practically by taking the values. Okay, so we will assume opposite by hypotenuse as sin theta, adjacent by hypotenuse as cos theta, and opposite by adjacent as tan theta. And we have secondary ratios which are dependent on primary ratios, and the relation between the primary ratios and secondary ratios is nothing but the reciprocals. Now the reciprocal of sin theta can be assumed as 1 by sin theta is equal to cosecant theta. So since it is reciprocal of sin theta, it is defined as cosecant theta is equal to hypotenuse by opposite. Remember, sin theta is equal to opposite by hypotenuse, and its reciprocal cosecant theta is nothing but hypotenuse by opposite, H by O. And similarly, reciprocal of cos theta is defined as secant theta, and it is given as H by A, hypotenuse by adjacent. And in the same fashion, reciprocal of tan theta is given as cot theta, and it is given by adjacent by opposite. So in this way we have totally 6 ratios which are derived from the triangle, and we will assume so what we got exactly here is based on the assumptions that opposite by hypotenuse can be assumed as sin theta, adjacent by hypotenuse can be assumed as cos theta, opposite by adjacent can be assumed as tan theta. Okay, so for this thing we have to remember sin theta, cos theta, tan theta, and reciprocals of sin theta are cos theta. Reciprocal of sin theta is cosecant theta. reciprocal of cos theta is nothing but secant theta, reciprocal of tan theta is cot theta. Okay, then now we will start proving the trigonometric identities. In the beginning we have three identities, namely sin square theta plus cos square theta is equal to 1, and secant square theta minus tan square theta is equal to 1, cosecant square theta minus cot square theta is equal to 1. So let us take the first identity and let us prove this thing. Okay, see here, sin square theta plus cos square theta is equal to 1. Let us consider the left hand side part, LHS. Now we got sin theta. We got sin theta as opposite by hypotenuse. Sin theta as opposite by hypotenuse. So replace it with. So we can write sin theta as O by H whole square, and cos theta as A by H. Cos theta as A by H. So A by H whole square, and we have to prove it as 1. Okay, so I can write it as O square by H square, and this thing as A square by H square. Since the denominators are same, I can write it as O square plus A square by H square. And we know that from Pythagoras theorem, opposite square plus adjacent square is equal to hypotenuse square. So I can replace O square plus A square with H square. So substitute here. So H square by H square, which will in turn give the answer as 1, and that is what we are actually needed to prove that thing. So now the identity was proved. Sin square theta plus cos square theta is equal to 1. Now based on this, we can prove remaining two ratios, either by taking the right angle triangle values, or from the first identity we can prove that thing. See here. So we know that sin square theta plus cos square theta is equal to 1. Now divide it with cos theta on both sides. But before doing it, let me tell you one thing. We have one more important formula, that is sin theta by cos theta can be assumed as tan theta, and reciprocal of tan theta is cot theta. So that's why cos theta by sin theta can be assumed as cot theta. So we got sin by cos as tan theta, and cos by sin we will assume it as cot theta. So remember this thing. Now coming back to the second identity proof, we got sin square theta plus cos square theta is equal to 1. I already told you to divide it with cos theta. Now, cos square theta. Now it will become sin square theta by cos square theta plus cos square theta by cos square theta is equal to 1 by cos square theta. See, I am telling you clearly that we have to divide the entire equation with cos square theta. So on dividing the entire equation with cos square theta, we got here sin square theta by cos square theta plus cos square theta by cos square theta is equal to 1 by cos square theta. And sin square theta by cos square theta, as mentioned earlier, it can be assumed as tan theta. So it will be tan square theta, and cos square theta by cos square theta is equal, it's nothing but 1, because both are same now. It will be getting cancelled, and 1 by cos square theta is nothing but secant square theta. Now if you send tan square theta that side, so 1 is equal to secant square theta minus tan square theta, and there ends our proof. So therefore secant square theta minus tan square theta is equal to 1, and yes, we got this identity proof. Okay, so once you get the first identity, it is very easy to prove the second and third identity by simply dividing it with cos square theta once and sin square theta once. Now let us get back to the three identities, and we got this thing. And by using the first identity, sin square theta plus cos square theta is equal to 1. Let us now divide it with sin theta on both sides. Let us now divide with sin square theta on both sides. Now we will get sin square theta by sin square theta plus cos square theta by sin square theta is equal to 1 by sin square theta. Since sin square both are same, here we will get 1, and cos square theta by sin square theta, as we already mentioned, sin by cos is known as tan and cos by sin is known as cot. So here we'll get cot square theta and is equal to 1 by sin square theta. We can write cosecant square theta. So if we send cot square theta to that side, we'll get 1 is equal to cosecant square theta minus cot square theta. So cosecant square theta minus cot square theta is equal to 1. And yes, we are done with the third proof also. So in this way we can prove these three identities. Okay, so these are the actual proofs which are referred from a standard book. Okay, so no need to worry about all these things. And yes, these are very important, and one should keep them in mind for solving any equations and which are involved in trigonometric. Okay, so see, it is like whenever we see the problem involving sin theta and cos theta, we should remember all these three identities and they should be revolved in our mind. Okay, so if you somewhere in the question, if you see the cosecant theta and cot theta, so immediately you have to strike out, immediately you have to get the idea of this third entity, cosecant square theta minus cot square theta is equal to 1. Like what I am telling simply is nothing but whenever you are getting sin theta and cos theta, or secant theta and tan theta, or cosecant theta and cot theta, you should be able to remember these identities and you should be able to apply these identities and solve the answer. So right, so this is the main proof of trigonometry identities, and that's it. Thank you.